Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at factoring something called the difference of squares. So before we do that, we'll do a little review of FOILing. So if I look at the first bullet point here, the x plus 4 and the x minus 4. When I FOIL, I would get x squared, right, and then minus 4x plus 4x minus 16. When I combine like terms, the x terms go away, they make 0, and I'm left with x squared minus 16. So get another one. What if I FOILed the next bullet point? Well, I'd have 25m squared minus 5m plus 5m minus 1. Combining like terms, I'm left with 25m squared minus 1. And then if I do the next one, I would get 4a squared minus 6ab plus 6ab minus 9b squared. They go away, and I'm left with 4a squared minus 9b squared. All of these, as it says here, the result is called the difference of squares because we are subtracting two terms here, and each term is a perfect square. In other words, I'm able to take the square root of both terms here to get a non-decimal answer. So how to factor them? Well, first you need to make sure they're in these forms here. So you want to make sure the actual difference of squares. There must be a subtraction sign, and you can square root both terms. Then the following rule applies. The factored form would look like this. A plus b times a minus b. And then you're just going to check your work by distributing, because we always check our work. So if I look at the first one, again, we can have some polynomials that cannot be factored, so we're just going to write prime. So if I look at this one, a squared minus 4, I'm going to check. It has a minus term, and I could take the square root of both sides. A squared is the square root of a squared is a, and the square root of 4 is 2. One thing to note here, anytime there is a even exponent, it's always a perfect square. So 2, 4, 6, 8, all those. So if I take the square root of both these terms, the square root of a squared gives me a, and the square root of 4 gives me 2. So those are my a and b that go in parentheses. A plus 2, a minus 2. So get another one. Let's look at number 3. 81 minus x squared. I'm going to check. There's a minus sign. And is each term a perfect square? Yeah. 81 is a perfect square. X squared is a perfect square because I'm able to take the square root of each term. I get 9 for that, and I get x here. So my factored form would be 9 plus x, 9 minus x. Let's look at number 5. K squared plus 25. Right away, some bells should go off here because look what I have. I have a plus sign. Even though k squared and 25 are both perfect squares, because I have a plus sign, this is not a difference of squares. In fact, this answer is prime. That is as simplified as it can be here. All right, let's look at number 7. 9b squared minus 100. I have a minus sign. Are these two terms perfect squares? And they are. I'm able to take the square root of both sides here. The square root of 9b squared is 3b. The square root of 100 is 10. So my factors for my parentheses would be 3b plus 10, 3b minus 10. Same thing for number 9. Take the square, it's a minus sign, and I could take the square root of both sides. Square root of 16a squared is 4a. Square root of 121 is 11. So my factor form would be 4a plus 11, 4a minus 11. If I look at number 11, minus sign, can I take the square root of both sides? Yes, I can. Square root of 4h squared is 2h. Square root of 25g squared is 5g. So it'll be 2h plus 5g, 2h minus 5g. All right, let's keep going here. Let's look at number 13. Again, I have a minus sign. And do I have perfect squares? Well, we should all know the square root of 1 is 1. The square root of x squared, y squared. Yeah, they both have even exponents, so they are perfect squares. That's xy. So my parentheses would be xy plus 1, xy minus 1. Let's skip number 15 because it's... Oh, actually, let's just do 15. Okay. I have a minus sign here, but 4c squared, that's a perfect square, but 5d squared? D squared is a perfect square, but 5 is not. So this is also prime. All right, now let's look at number 17. Now 17, I have k to the 6 minus 16. So again, you want to see, are these two terms perfect squares? Well, 16 is a perfect square, that's 4. But is k to the 6 a perfect square? It's an even exponent, so yes, it is. Now the question is, what is the square root of k to the 6? Well, to figure that out, the reason why even exponents work is because they're divisible by 2. So take the exponent, which is 6, and divide it by 2, and I get 3. So it's k to the third. So my parentheses would be k to the third plus 4, and k to the third minus 4. And then if we just finish off with number 19 here, we have a minus sign, and these two are difference of squares. So the square root of 1 is 1. The square root of 121 r to the 6. Well, the square root of 121 is 11. And I take the exponent and divide by 2, and I get 3. So my parentheses would be 11r cubed plus 1, and 11r cubed minus 1. Again, if you have questions or you got lost somewhere, pause the video now, go back and rewatch the area that you got confused with. All right, so the way that these get harder is you might have to find a GCF first. And that's with any of the factoring I'm going to be doing. You got to look for, is there a GCF? So, if I look, 21, is there a GCF? The answer would be yes. There's a 2 I can factor out. Well, what's left over? N squared minus 36. And then as the problem says, what's left over, can that still be factorable? And yes, it is. This is a difference of squares. Square root of n squared is n. Square root of 36 is 6. So my final answer is, can't forget this 2, and then n plus 6, n minus 6. All right, how about 23? Is there a greatest common factor? Is there a GCF? The answer would be what? It would be yes. It's a 2. So let's see what's left over. 16s squared minus 9u squared. Yep, this is a difference of squares again because there's a minus sign, and I can take the square root of both terms. The square root of 16x squared is 4s. Square root of 9u squared is 3u. So my final answer, and I'll write it to the side here, would be 2, 4s plus 3u, 4s minus 3u. Let's look at, let's skip 25 here. Let's look at 27. 27, is there a GCF? Yeah, sure is. The GCF of 80 and 125 is what? It's going to be 5. So I factor out 5. And also, I have an n to the fourth and n squared. So I would have to factor out also an n squared. What's left over? Well, 80 divided by 5 would be 16. N to the fourth divided by n squared is n squared. Minus, and then when I divide this, I get 25. Oh, look at here. Difference of squares again because I'm able to take the square root of both terms. Square root here is 4n. Square root here is 5. So my final answer would be 5n squared times 4n plus 5, 4n minus 5. There, that goes for here. We'll do one more example here, or two more, let's see. And we've got 29. Again, what's the greatest common factor that goes into both evenly? Well, the answer would be 9p. What's left over? Well, 4p squared minus 1. We have a difference of squares again. Square root of 4p squared is 2p. Square root of 1 is 1. So my final answer is going to be 9p, 2p plus 1, 2p minus 1. Yeah. Let's see. Let's look at number 31, I guess. So again, is there a greatest common factor? And there is. The greatest common factor here would be 4k. When I divide each term, I'm left with 4k squared minus 25. Lo and behold, difference of squares again. So this is going to be 2k, and that's going to be 5. So my final answer is going to be 4k, 2k plus 5, 2k minus 5. And that, ladies and gentlemen, is how you factor difference of squares. Again, the key thing is you always want to make sure for any of these that we're doing, you're finding is there a GCF first. Once there is or is not, then you can go about doing these different methods. There will be more, don't worry. But right now, we're just doing step by step so you can get all of it. So your homework here, yeah, would like you to do the odds for me, all right? Again, if you have any questions or concerns, please feel free